Welcome to our lesson 7. We are dealing with errors. Okay, this is Form 3 work. You have approximation and errors. Approximation deal with the way you finish your work answer. The answer can be asked to be finished in 3 significant figures, or 2 or 4 and so on, or 1 decimal place. That is how you are asked to approximate your answer. Errors deals with measurements, okay? And we do measurements using different devices which have different levels of accuracy. So this is question 2 of paper 2 last year. They asked some questions on errors. We were given the measurement of 2 students. One I've written S1, so this is student 1 measures 30.5 kg and student 2 measures 36.8 kg. Now these 2 students, we can say their measurements were taken to 1 decimal place. When we have 1 decimal place, you can easily get the absolute error. You just do 0.1. I can do it side here. 0.1 divided by 2, you get 0.05. That would be absolute error. Absolute error gives you what was the possible maximum approximation and what was the least possible approximation that would lead to either 30.5 or 36.8. In other words, this, if you add to this, it gives you that. This is the maximum possible figure which was rounded off to this. So I know you, in your mind, you will say 30.55 should be 30.6. No, these are overlapping figures which marks the beginning of another figure. So that one a teacher should be able to elaborate more. All these limits, the upper limit becomes the lower limit of the next figure. So they overlap. We are saying that is the boundary. Okay? So from this and that, remember, it is to 1 decimal place. So I can write 0.1 and then I divide by 2. Then it gives me 0.05. So 0.05, essentially when you add to this, it gives you the maximum limit, the upper limit, and when I subtract 0.05 from this, it gives me 30.45. So that is the lower limit. In other words, 30.45 approximately is this. 30.46 is approximately this. And so on until you get to 30.54. 30.54 makes sense. 30.55 a bit disturbing to students, but we say that figure serves 2 purposes. It is the maximum limit for this, but it is the lower limit of 30.6. So we take this because they have to be symmetrical. The figures, as you count, 30.45, 30.46, 30.47, 30.48, 30.49, and then you go to 30.5. So those ones which are below 30.5, their number must equal to those which are above 30.5. So we say they are symmetrical. Okay? We will do the same to this because they are measurement to one decimal place, so you get absolute figure. Now, the absolute comes in the sense this way. Many students wonder absolute is what? If you take 30.45, subtract 30.55, you will get a negative number. But we are not interested in that negative. That's why we call it absolute error. There are some errors that are above and there are some errors that are below. I'm repeating. If you take 30.45, subtract this 30.55, you will get negative 0.05. You see there is a negative. If I take this, subtract this now. If I take this, subtract this, I'll get a positive 0.05. So this minus that. In other words, the differences we are getting here, there are others which are negative and the other is positive. But when we say absolute, we say omit. We are not interested in the sign. That's why we say absolute. Absolute error. Now, what you need to know in this topic, there are three major areas where we test. They can test sum or difference, okay? Sum or difference of numbers. That can be tested. We can test about product. We can test about quotient. All these you must know. When I have the maximum figure and I have the minimum of the other figure, what happens when I add, when I subtract, when I get product, or when I divide? So basically, you are talking about addition, subtraction, division, and multiplication. What happens when you have a maximum and a minimum figure? What happens when you add, subtract, divide, multiply? So I've given you a brief picture here. Okay? A brief picture is down there. But let us go to the question. Our question wanted least possible difference. So when you have student 1, his maximum possible weight was this. Minimum is that. A second student, maximum weight is that, minimum is that. So if I'm asked, what is the least possible difference? Then it is S2 minimum, subtract S1 maximum. Minimum of S2, maximum of S1. Maximum difference, minimum difference. Take a pen and do one by one so that it sticks. But I've given you a rough idea. This would be my chart, and that is how you get it. So you will take the weight of student 2, the minimum, which is 36.75. You subtract the maximum weight of student 1. His maximum is 30.55, and you get this. So this is our answer. So you can have, that. Then you can have a B1 there, the interpretation, so that you come up with maximum and the minimum. Now, this is a footnote. Okay, you can do for yourself the sum. What is the maximum sum? Okay, maximum sum. We've done least possible difference. So do maximum possible sum. What would be the maximum? Then others that are tested are product. I've tried to show you product. Okay, if I want maximum product, I'll take S2 maximum and S1 maximum. If I multiply maximum and maximum, I'll get maximum. Okay? and minimum, multiply and minimum. So this is multiplication, okay? This is multiplication. This is multiplication. Then you come to quotient. If I take the maximum of student 2, I divide by minimum of student 1, I'll get maximum quotient. And if I get the minimum weight of student 2, and I multiply by the maximum of student, this is student 2 is minimum, and then student 1 maximum. Then I'll get a quotient that is minimum, the least quotient. So minimum quotient is least quotient. So if I ask you about least quotient, then you should know it will come from the interpretation of these figures. Thank you, folks. Keep on subscribing. We meet next lesson. Bye-bye.